Swayam Prabha. Digital India. Educated India.
So here is some example of when we take the different lambda. So you now will please say which one has the maximum lambda. Do you remember what is the lambda? This one is the lambda. I did not write, that's why. What is the lambda for these things? Now you'll be, some of you will be saying me which classifier has maximum lambda here. If you have give larger lambda means more? No. So just think. Okay. Here, lambda is in this side. So when you have the lambda is higher, then you will give more weightage on the misclassification. So your margin will be narrower. So lambda larger, margin will be narrower. Lambda smaller, margin will be wider. Okay? It's clear or not clear? You tell me if you have. No? Okay, good. This is what? This is misclassification. And this is inverse of margin. Right? Now, in one place you have margin 2 and the misclassification 1, and you wear the lambda here 1. So your objective function, this value, the objective whole thing's objective value was 2 plus 1 equal 2 plus 1 equal to 3. Now you increase your lambda. Instead of 1, you put 10. So you will be having this, for this same W, it will be 10 into 1. So it will be then 12. It will be have 12. So if you have some other now classifier where it is giving the this is 3, but the misclassification will be 0.5. And here you have 10. What is the value here? It will be 8. So which one, with your lambda 10, which one you will be choosing? And with your lambda 1, which one will be choosing? Lambda 1, lambda 10. You have two classifier where W equal to W1 is 3, B1 equal to so not to be. So you have two classifier where this equal to. So you have two classifiers. So the classifier 1 will have this norm of W1 is equal to 3 and xi I for classifier 1 equal to 0.5. And you have another classifier where W equal to 2 and you have xi sum over I, xi of second classifier is equal to 1. And you have two lambda, lambda 1 equal to 1 and lambda 2 equal to 10. Now when lambda equal to 1, which one will be the best classifier for among these two? So what will be the objective function value for this one when lambda 1? So maybe we can check for lambda 1 it is 3.5. For lambda 10 it is 8. And for this one, for lambda 1 it will be 3. And for lambda 10 it will be 12. Okay. Now you take lambda 1 equal to 0.01. So, no, okay. I gave some, I think this 1 plus 1 into 1, it will be something like, okay. So this is okay. So these are the two classifiers. So it is lambda equal to lambda. So we have 3 lambda, lambda 1 equal to 0.5, we have lambda 1 equal to 1, and lambda 3 equal to maybe 2. So we'll having 3 things. Lambda 0.5 is equal to going to be his 6, and lambda equal to 1 is 11, and lambda equal to 2, this one is 21. And for these things, lambda 0.5 is equal to 10.5, lambda 1 is equal to 11, and lambda 2 equal to 12. Right? I think I did mistake, so my previous example also was correct. Okay, now you think your lambda 1 equal to 0.5. Which classifier you will be selecting? Classifier 1 or classifier 2? Lambda equal to 0.5, this is going to give you this objective function, and this is going to give you 6 and 10.5. Which is less? 6.5. So you will be selecting the classifier 1. When lambda equal to 1, both the classifier will get the same weightage, so you will be selecting something randomly. And when lambda equal to 2, then which classifier you will select? Which is giving the less objective function? Second one. So then when lambda equal to lambda 3 equal to 2, then we'll be choosing second classifier. Okay? Right? So it will be saying like if you increase the lambda, then you will be turned off to choosing some classifier which has more this value. So this is if lambda, this is for lambda 3, this is a greater than lambda 1. So this is more, so this more means margin less. Right? So when the lambda is high, you will be giving more weightage to minimizing your classification error. So the lambda when high, your margin will be less, and also your misclassification error will be less. When lambda is less, then we are choosing these things. So this will be minimizing more. So your margin will be more, and your misclassification will also be more. So this is inverse of margin. That's why if you see this is the inverse of margin, then it will be different. When this decreases, the inverse of margin increases, and when the error increases, the inverse of margin decreases. If you take the inverse of margin. So when lambda is more, the inverse of merging more and the error less. When lambda is less, then inverse of margin is less and error more. Okay? So now here, which one has the highest lambda? Which one has the highest lambda? Fourth one has the minimum margin. And which one has the least lambda? First one. Very good. Now it comes to the hinge definition of hinge loss again. So think about what is our loss for the support vector machine is the xi I. And what is the xi I? Xi I is maximum of either 0 or the number which we can calculate 1 minus wi into yi into w transpose xi plus b. What is the violation? The violation can be either some positive numbers or it can be a 0. If the violation you were thinking it is a negative, then there is no violation, so it will be 0. Right? So if it is more than 1, this side it is y into this w transpose x plus b. So if it is a more than 1, this is 0, and if it is a less than 1, that is this is increasing monotonously with a hyperplane, with a line, where so when it is 0, then it is be exactly 1. So in turn, when we are minimizing the xi I in support vector machine, that is why we are minimizing this loss, which we called hinge loss, because it looks like a hinge in your door. So how to solve SVM? So instead of writing it as a constraint optimization problem where we have a xi in our objective function and we have some constraint over xi, we can directly put this loss, this xi I, it's this one, in our objective function, and we can just omit this part. And then it will be an unconstrained optimization problem. Do you have any idea how you can solve any unconstrained optimization problem? Do you know any tool to solving an optimization problem? Yeah, have you heard about the gradient descent, Newton methods? Those things have you heard? So maybe you can take any of this method where in every step will be change our parameter such that the loss or the functional value decreases. So we'll be step by step we'll be going to the optimizations. So but here where it is the hinge loss, it is not smooth. So this differential does not exist. So in that case we generally use subdifferential. So I am not going into the details. If you have some specific questions, if you want to know this what is subdifferential, you can Google it, and if you are not clear, you can email me. Okay. But you can think you have to choose any directions which will give a decrement in your objective function and update your parameter in that directions. Okay, here also again this is not depend on the number of data points. So this algorithm is not in order of n. It does not depend on the data points. So here it is the linear support vector machine we draw, or we have learned on this the same data set, and we got this kind of. Okay, now it is a questions for the multi-class. How we do for the multi-class? SVM is always for the binary class. So you have two options for doing SVM for the multi-class. Do you know what are the options? Few people know what is the SVM then. Do you know? There are two. One is 1 versus 1. That means if you have 3 class, that is C1, C2, C3, and you have to choose any 2 of this class, you have to make some classifier. So SVM on C1, C2, SVM on C1, C3, SVM on C2, C3. Okay. So if you have this type of data, so this is the blue data, this is red data, and this is the green data. So whenever you are learning, then with the blue and red you will be learning this is as a classifier, and with the green and red maybe you will be learning this is a classifier, and with the green and the blue will be learning this is the classifier. So it can be your own versus 1 can be like this. Then how you will be classifying this point here? So when you are considering the classifier between blue and the red class, it will give you the class blue. When you are comparing it with the green and the red class, it will give you class, which class? Which class it will give? Your classifier? When you are comparing red. And when you are comparing these things, blue and green, it will be giving this side of this hyperplane, so it will be green. So in that case, one way to classify it to consider this function. So for all these three data, classifier you will be having some function, no? W transpose x plus b, b1, another is W transpose x plus b2, another is W3 transpose x plus b3. We know if it is this yi, so if it is the more value it has, it will be giving the away, it is more away from the hyperplane. So in that case, you can use these functional values and you can choose your classifier, your class. Okay. So and then there is another thing, it is we call one versus all, and there we can say that C1 and then versus C2, C3, and then other classifiers C2 versus C1, C3, and C3 versus C1, C2. And there also, if you have some point which has given both the classes C1 and the C3, then you can again use this function to find out the class. Okay. So now here I have learned a SVM classifier, linear classifier, linear hyperplane for these three data points, and this left hand side is a training data points, and this training error is 5%, and this is the test data point. Here the test error is 5.56. Very here I have optimized the lambda. How to optimize lambda? Again by cross validation. Okay. Okay. Now it comes if our data is something else. So maybe we'll go here. So if our data is something like this, so this is the low, then a linear classifier will not work, right? We should have some non-linear classifier. It should be like this, and this part, these two parts are red, and this part is blue. How to get this kind of classifier using SVM? One trick is that you can transfer it to some other space, your data. So here maybe this data points has 0, 0, and this data points has 1, 1, and this has 0, 1, 0, and this data point value as 0, 1, right? So you can think about only 4 data points, and then if you transfer this, so it has 2 feature x1 and x2 in this space. Then you transfer this to some other space which will contain maybe some thing like some XOR function you can use. So you will create some other space like x hat, and there maybe you can use the square function. So so it will be something like, then you will have x1 is x1, other is x2, another will be x1 x2, and the other things will be x1 square and x2 square. So these from the 2 features, 2-dimensional feature space, you are moving to 1, 2, 3, 4, 5-dimensional feature space using some basis function. This is we called as a to transfer your data to high dimensional space. Now when you have these 4 data 0 0 0 1 1 0 and 1 1, if you put it there, so this will be 0 0 0 0 0, and then it will be, when it will be 0 1, then it will be again 0, it will be 0 1, and here it will be 1 0, and it will be 0, and this will be 1 0, and here it will be 1 1, it will get 1 1 1. So now you can think about writing a class like this W1, so it will be like half of x1 plus half of x2 and minus x1 x2. So these are your W's. We have to write this way, no, some function this way, W transpose x. So when your W is something like half 0 0 0, then you will be getting these functions, and if you put these functions here, maybe you will get a hyperplane, which were not possible by using this one. This function will be learning when we have, this is, I have given only some example, this is our W, but when we don't have it, we will have these things, then it will be moved to some other space where it will be, if you think about this space, x1, one is x1, other is x2, another is x1 x2, then it will be some, these blue points will be coming in some places here, and then red point will be coming in some spaces here, and then you can draw a plane in between these two, you can draw a plane like this. So how to transfer from here to here? What is the basis functions? Yeah, that will also depends on, this is subjective, again depends on that you have to find it by the cross validations, like which functions are, which bases are good. You can use the radial basis function, and you can use some other function, some polynomial functions. So there, that is called that which kernel we are going to choose, and it will depend on what do you want the how do you want the complexity of your classifier. So if you want this to be very complex classifier, you use Gaussian kernel or radial basis function. And if you want a polynomial classifier of degree 2, then you just use this polynomial of degree 2. If you want a polynomial of degree n, then use the function polynomial of degree n. That will be depend on how the classifier you want. Yes? Actually, you have to try all possible function, all possible complexities, and find it out, but which one the best by the cross validation. This is a hyperparameter. This is like a hyperparameter. But in generally, this Gaussian kernel or radial basis function are used universally, kind of. So this is with the help of Lagrangian trick, Lagrangian multiplier, we can write our objective function like this, where here alpha and the gamma are the Lagrangian multiplier. Think we can, you just take it that we can write it in this way. There are some theorems in behind that why and how we can write it in this way. By the Lagrangian theorems are there, but I am not going into this. And then if you take the derivative with respect to w of this function, so when you want to minimize, you want the derivative of with respect to w of this function will be 0. That is a minimum, that is optimum point. So when you take the derivative of this function to be 0, you will end up in getting these things, that w is equal to this sum. This alpha I, yi, xi. These alpha i's are for all samples, each one alpha is there, and again this gamma also, there is one sample. And again, when you take the derivative with respect to this b, then we will get that 0 is equal to the derivative, it is like this is, you take the derivative of w with respect, derivative of this function with respect to w, equal to 0, and this is derivative of this function with respect to b equal to 0, then you will get this function. And here when you take the derivative of this function with respect to xi I is equal to 0, then we will get this. This gamma and alpha calls Lagrangian multiplier. Okay. So no, this is a parameter, like W is there as a parameter in our primal formulation. Now we are going to get a dual formulation of SVM where this alpha and the gamma are our parameter. So this is the Lagrangian function. Now we are minimizing this Lagrangian function with respect to our primal parameter, that means W, B and xi. And when we are minimizing, we are finding that with respect to W, B and xi, this derivative of this function is going to be 0 at that optimal point. So we get this 3 set of equality. And then we replace this W and we replace these things in these functions. We remove B and we remove xi and we remove W from this function by using these equalities. And then we will get a function that will be only a function of alpha and this gamma. Then this function will be again optimized. That will be the dual optimization problem, where the dual variable or dual parameters are the alpha and the gamma, and will be maximizing these things.